Helen Hayes once said, "The expert in anything was once a beginner." Let's look at this question, but before we do, let's go and check what is photoelectric effect. Photoelectric effect, the word photo means light, and then electric, we know that it's another form of energy. So it means in this topic we are going to check the relationship between light and energy, photoelectric effect. So what we need to know about this topic is that if we have a light, any light shining on a metal, any form of metal, the light particles or the light travels and shine on the surface of a metal. There will be electrons emitted or ejected. There will be electrons emitted from the surface of the metal. So what we know is that light has particles, and the particles of light is called photons. Photons are the particles of light, of which when they shine on the surface of metal, they emit electrons from the metal. And then these photons, they have their own energy, they have their own frequency. And this metal has its own energy, the energy that is needed to be overcome by the energy of light in order for electrons to be emitted, which is called the work function. And with the frequency of the metal, the frequency that is needed to be overcome by the frequency of the light in order for electrons to be emitted is called the threshold frequency. So this is what we need to know. And then for the electrons to be emitted, the conditions needed is that this energy of light must be greater than the energy of the metal, which is the work function. So this is the condition that is needed for electrons to be emitted. Or if the energy of the light is less than the work function, it means there would be no emission of electrons. Same applies with the frequency. This frequency of light must be greater than the threshold frequency in order for electrons to be emitted. So it means here we'll have the emission, here we'll have no emission here. And if the threshold frequency is greater than the frequency of the light, it means there will also be no emission. So this is the conditions, or these are the conditions needed for us to check whether electrons will be emitted or not. And then we have a formula to calculate the energy of the light. And how do we calculate it? We can use this formula. Energy of the light is HF. This H is Planck constant, is there on our information sheet. The Planck constant, we have it on our information sheet. This is the frequency of light. Or if we don't want to use this formula, we can use E is equals to hc over lambda. So this H is still the Planck's constant, and then the C is the speed of light, which we get on the information sheet. And then lambda, we know that is wavelength from grade 10 and 11. It must be in meters. So we can use either of these formula to calculate the energy of the light. So the question is, how do we calculate the work function? The formula is there on our formula sheet. We have H and then the threshold frequency. Work function is equals to the H and the threshold frequency. And then we also have another formula to calculate the energy of the K. This K is kinetic energy, and we know that kinetic energy is the same as 1 over 2 mv squared. So we can calculate it by substituting with the E and the WO, which is the work function. And we already know these variables, the meaning of each variables there. So this is the energy of the electrons. Once they get emitted here, they have the energy, the kinetic energy, which is this K max. So this is the energy of the electrons. I think we have covered the best part of photoelectric effect. If there's something, we'll check it later. For now, let's go back to the question. Let's go and look at the question. So here's the question. We are told that a potassium metal plate, which is this one, is irradiated with a light of wavelength. We have a wavelength here, which is lambda. we have a wavelength of 5 times 10 to the negative 7 meters. This is a wavelength in an arrangement as shown in the picture here. So we have the threshold frequency of the potassium, which is 5.55 by 10 to the negative, oh, not negative, to the 14 hertz. And then the first question we're asked to define threshold frequency. Threshold frequency, we have already defined it, is the minimum frequency that is needed to overcome, is the minimum energy needed to emit electrons. So that is threshold frequency, minimum frequency. And then calculate the energy of photo incidence on the metal. This time around we need the energy of the photons, and we said that the energy of photons, we can use either this formula or this formula, H F, any of this formula. So but according to the information that we have, we can use the first one. So the energy of the photons, we have H, which is the Planck's constant, 6.63 by 10 to the negative 34. And then we have a C, which is the speed of light, 3.0 by 10 to the power 8. And then lambda, we know that is the wavelength, negative 7. And then when you punch this on your calculator, we should get 3.98 by 10 to the power negative 19 joules. So this is the energy of the light. So this light must have this energy, which is 3.98 by 10 to the negative 19 joules. And then the next question, we are supposed to use suitable calculations to prove that the ammeter will show a reading. So for this ammeter to show a reading, it will only show a reading if the electrons are emitted. And we know that for electrons to be emitted, it means that the energy of the light must be greater than the work function. So now we are supposed to prove by calculations. We already know this E, but we don't know the work function. So it means now we're supposed to determine or to calculate the work function, 10.3. The work function, how do you calculate work function? Work function is equals to, this formula is there on our formula sheet. We are given the threshold frequency. This H is there on our information sheet, which is 6.63 by 10 to the negative 34. And then the frequency, which is the threshold frequency, is there on the statement. And then when you punch this on a calculator, we should get 3.68 by 10 to the negative 19 joules, since it's an energy. So but now if you can check, we have two energies here, same decimal place, but then same decimal place. So this one is 6.8, this one is 9.8. So it means that this E is greater than this work function here, meaning that electrons will be emitted. And as electrons are emitted, it means that the ammeter will show reading or will register a